Good morning, fifth graders. Today is Wednesday, December 16th. It is an independent learning day. That means you are going to watch this lesson video and then do your work without having math class with me. So this replaces your math class. Our learning target for today is I can rename mixed numbers and improper fractions. I wrote a to-do list on here in case you are wondering which class job should be. First, you're going to watch this whole lesson video. Then you're going to do your Wednesday work on your Google Slides assignment. Next, you're going to make sure that all of your work from Monday and Tuesday slides are done. Then I would take a look at your grades in Schoology, work on any missing or incomplete work. And if you have any extra time, spend it exploring the Unit 4 resource folder where there's a bunch of games where you can practice fraction skills. And then if you need help, the best place to look would be at the Unit 4 anchor chart slides. There is a link in Schoology in the math folder for you to look at this. Okay, the first thing that we're going to do is do a quick little review of our learning target from yesterday because it is important for you to be able to do this to meet your learning target today, which is renaming mixed numbers as improper fractions, but you should be able to also do the opposite, renaming improper fractions as mixed numbers. Okay, so yesterday when we did this, we had a couple different steps. I'm not going to have them written out on here. If you need that, you can jump onto the lesson video. But what we want to do when we are finding our mixed number form of an improper fraction is we are trying to find out how many wholes, or 6/6 in this case, equals one whole, we can make out of 22 1/6 pieces. Okay, in order to do that, we're going to use division. So we're going to divide our numerator, 22, by our denominator of 6. And I saw students doing this in a bunch of different ways yesterday. Some of them were using skip counting. Um, some were using related facts. Some were using partial quotient. Whatever way you want to do this division, you totally can. I know that as close as I can get 22 with 6 is 3 times, and that is 18. And then we are going to subtract and get 4. Okay, now one step we did not have on our step list yesterday, actually, I think we added it, but is to make sure that when we bring up our numerator here, our remainder, our leftover, and make that our new numerator, sorry, remainder, make that our numerator, we keep our denominator the same as the divisor or the same as it was, 6. Now we have 3 and 4 6. So the one thing I asked you to do yesterday is make sure that your fraction part of your mixed numbers also in simplest form. So ask yourself, what are the factors of 4? What are the factors of 6? Can we further simplify that? Okay, so I'm just going to real quick make my factor list down here. And I see that they share a common factor of 2. So what we can do is divide each our denominator of 6 and our numerator of 4 by 2. We will get 2/3. Remember to keep this whole number part. So I'm going to rewrite this one more time as 3 and 2/3. There's our final answer, a mixed number that is equivalent to 22 6. Okay, now we're going to do the same on this side. We're going to divide 36 by 8. We are trying to figure out how many 1 wholes, or how many 8/8 we can make out of 36/8. You see, as close as I can get is 4. 8 times 4 is 32, and we're going to have a leftover of 4. Now, I can't break those 4 pieces into 8 groups, or I can't make another 1 whole with those. So that means this 4 is going to come up and become my numerator, 4. Denominator stays the same, 8. And right away, even without having to make that factor list, can you see that this fraction 4/8 is not simplified? Some of you might be making that connection right away, that 4 is half of 8, and you might recognize that as 1/2, that benchmark fraction. Otherwise, if you want to make your list of factors, you can. I know I'm going to be able to divide by 4, and I'm going to draw an arrow down here because I kind of ran out of room. Our final answer will be 4 and 1/2. Okay, so today your learning target is very related to what we just did on the last slide, but instead of using division, we're going to do something a little different today. Now, this first one, I'm going to draw a model so that you can see this happening, kind of like we did with our first problem yesterday. Um, Again, I don't think that drawing fraction models for mixed numbers to improper fractions is a super efficient way for you to do this or to solve these problems, but if that's the only way you know, then that is okay. I am just going to start by drawing a fraction bar, and I am going to draw, actually, I'm going to draw a couple fraction bars. I'm going to represent 4 and 1/3. So I'm going to end up drawing 4 holes because that is what that whole number 4 tells me to do. Draw one right here too. I want to run out of room. Okay, and then I'm going to partition those into thirds, which means I'm going to draw 2 lines down. Remember, your fraction models don't have to be perfect as long as you can get understanding from them. Mine are not all perfect or all equal. I'm going to use my other, and use this red marker here to shade in 4 holes. So 1, 2, 3. And I know that each one of these holes means that we have 3/3 or 3 out of 3 or 3 1/3 pieces all shaded in. Okay. And then because I have my whole number 4 and then 1/3 left over, I need to draw one more fraction bar. I'm going to partition it into thirds. And now this time, instead of coloring all 3, shading in all 3, I know we only have one of those. So we have 3/3 here, 3/3 here, and 1/3 here. Okay, so one thing you could definitely do to find out what this improper fraction is you could just go ahead and count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. You could do that, or you could say, hey, Miss Brocker, it'd be a lot easier for me to do multiplication because I see I have 4 times 3 and then one more. Okay, so you could do it that way. Or, just like yesterday, a little bit easier way. Okay, so here are our steps over here. We are going to, I'm going to scooch this up just a little bit. We are going to instead multiply our whole number times the denominator. And the reason why we're doing that is because if we know our whole number represents how many 3/3 we have, instead of adding 3 here plus 3 plus 3 plus 3, instead, if we do 3 times 4, we will already have how many 1/3 pieces are in each one of those holes. Okay, so we are going to multiply our denominator times our whole number. Okay, so I'm going to multiply 3 times 4. So one of your fact fluency facts is 12. Okay, check, done with that step. Next, we are going to add the new product, which is 12, answer to a multiplication problem, to our numerator. Because if we just do 3 times 4, we're missing counting this piece right here. And we still need that. Okay, to find out how many 1/3 pieces we have. So I'm going to show this by just doing an addition sign. And then I'm going to draw an equal sign to make my improper fraction. This is going to become the new numerator. So 12 plus 1 is 13. And our denominator stays the same. So it's going to stay 3. That does not change. So what this shows is that 4 and 1/3 is equal to 13/3. Okay, we're going to do 2 more of these all together today before you get off and do your practice. So this first one right here, we have 7 and 4/5. So we're going to go through with the same steps again. We're going to start by multiplying our whole number times our denominator. And our goal is to make or rename this mixed number as an improper fraction. And what we're going to do at first is find the numerator. We're going to find out how many 1/5 pieces we have. Okay, so we're going to multiply 7 times 5. And that product is 35. I'm going to write it right here. And all that that means, if I were to draw this fraction model, we would have 5 holes. And each one of those 7 holes, and each one of those 1 holes has 5/5 in it. So it's like we're taking those 5/5 and to figure out how many full 1/5 pieces we have, we're going to multiply how many pieces are in 1 hole times how many holes we have. Okay, so that's how I got 35, and then I'm going to add that to our numerator we already have. So 35 plus 4, 36, 37, 38, 39. So that is going to become my new numerator, 39, and my denominator, 5, is going to stay the same. That's it. Okay, now we're going to do this other side. Over here, we have 6 and 3/10. So that means that our 1 hole has 10 pieces. So 1 hole would be 10 tenths. And if we know we have 6 of them, then we can figure out how many 1/10 pieces that we have in our wholes. And then we just have to add the numerator, which is the leftover. So I'm going to multiply 6 times 10, and that is equal to 60. And then we are going to add our numerator, 3. That will give us our new numerator. 60 plus 3, 63. And then our denominator of 10 stays the same. Now, if you ever want to check your work on these, what you can do is what we did yesterday. We could divide 63 by 10. And what should happen is we should get our mixed number answers. So let's try that out just for this one. So I know I can make 6 equal groups, and that's 60. And I'm going to have 3 left over. This comes up and is my numerator, part of my fraction, makes my mixed number, and 10 stays the same. So I got the same answer there. Perfect.